Today, it is well known in paleontology that many species of dinosaurs had feathers or at least some type of filament on them. This was not always the case, and evidence of filaments on dinosaurs only started to come out during the mid and late 90s, initially out of China. Bird fossils had been discovered already, the first being Archaeopteryx, which was found in 1861. However, it wasn't known back then that birds are a type of dinosaur. This meant that no animal considered to be a dinosaur had any evidence of feathers. Side note, nowadays it's also uncertain if Archaeopteryx is actually a true bird or not. The first non-avian dinosaur to be preserved with filaments was the early Cretaceous consignated Sinosauropteryx prima. It was described in 1996 and is understandably an important discovery. In the 90s, feathers on dinosaurs had already been suggested due to the idea of the bird connection, and this specimen was the first real evidence for that. The holotype was a juvenile that was about 68 centimeters or 27 inches long. Larger adult specimens were up to 1.2 meters or just under 4 feet long. I'd say that it is a non-avian dinosaur, which is true. However, the first paper describing Sinosauropteryx found it to be in the class Aves, i.e. a bird. However, later a 1988 paper determined Sinosauropteryx to be a consignated coelurosaur. Some interesting traits of Sinosauropteryx and other consignathids are that the maxillary teeth are serrated like a typical theropod, but unlike a typical theropod, the premaxillary teeth are not serrated. They also have a large and robust first finger on the hand, and relatively short but strong forelimbs. Another interesting trait of Sinosauropteryx specifically is that it has a very long tail which had about 64 vertebrae in it. It was the longest tail of any theropod when the animal was discovered. Obviously, the filaments are the most interesting feature of this animal. They seem to cover most of its body and are thicker than the hairs of an equally sized mammal. There has been some uncertainty over whether or not Sinosauropteryx's filaments were true feathers. Most experts seem to agree that they were likely primitive feathers, specifically protofeathers, which are similar to the down feathers on a baby bird, both being Plumulose type feathers. Probably the most impressive discovery is that in a 2017 study, they were able to determine the colors of Sinosauropteryx's feathers. There were color pigments preserved in the feathers of 3 specimens, one of which being the holotype. The study found that Sinosauropteryx had what is called countershading, where it's dark on top and light on bottom, which helps animals camouflage. The animal's back was a brown or orange color, while the underbelly was white. This was the same for the base of the tail, until it switched to the same colors in a striped pattern. They don't know what benefit the tail could give. There are modern animals with striped tails, but the reasons for this to evolve are not well understood. The paper suggested things like social and sexual display, camouflage, or even distracting a predator from the vital organs of Sinosauropteryx. It could be any one of these or a combination. The paper did say that Sinosauropteryx may have had difficulty holding its tail straight since it was so long, which could potentially limit its use in display, but I'm not sure how certain that is. With the specific countershading on Sinosauropteryx, the scientists found that it would have been best for camouflaging itself in open habitats. Interestingly, the paper also states that most animals in the same environment as Sinosauropteryx were likely to have been more forest dwellers. For more information, you can see a video explanation in the actual paper, link in the description below. In addition to this pattern, Sinosauropteryx had dark bands around its eyes, called a bandit mask. This is similar to what raccoons have, and is also present in some birds. Some of the main reasons for Sinosauropteryx to have had the bandit masks are 1. To reduce glare, which helps in an open environment when it's sunny. 2. Social signaling to rivals or mates. And 3. Many modern birds with bandit masks have dark eyes. It's possible that this makes it harder for both predators and prey to see the bird's eyes, and this can help the birds. So perhaps this was also true for Sinosauropteryx. Again, the purpose of the bandit mask could be any of these, or a combination. So that is Sinosauropteryx prima, one of the most important dinosaur discoveries ever found. Hope you enjoyed the video, and thank you for watching.